Hey everyone, welcome back. And today we're diving into something that's like the backbone of a ton of science. Waves? Yeah, think about it. The music you're always listening to, the sunlight, the stuff that makes life on Earth even possible, even those crazy earthquake videos you see online, it's all about waves. But what are they really? So let's get right into it. What are waves?
Think of waves like messengers, all right? They carry energy from one spot to another. And the cool thing is, it's the energy that's actually moving, not the actual stuff the wave is, traveling through.
Okay, so it's not like, a basketball flying through the air.
Exactly. Like, picture a line of dominoes. You knock over that first one, and the energy goes down the whole line, knocking them all down, right? Even though each domino only moves like a tiny bit.
Okay, I get it. So are there different types of waves, though?
Oh, yeah, for sure. There are two main groups. First, we've got mechanical waves. These need a medium, some kind of substance to travel. Think about sound waves. They need air to vibrate and reach our ears,
So no air, no sound.
Basically. Now, on the other hand, we've got electromagnetic waves. These are the cool ones that can travel through space like no substance needed, like light from the sun. The reason we're all here is a great example.
How do we tell one wave from another?
Each wave has its own, you could say, fingerprint, a set of things about it. We call them properties. These properties help us tell waves apart and figure out how they'll act.
Okay, properties, lay it on us. What are they?
First, we've got wavelength. Think of it like measuring the distance between the peaks of two waves. Imagine a short board versus a long board, right? The short board has a shorter wavelength for quick turns, and the long board with its longer wavelength is all about just cruising. It's kind of like that with waves. The wavelength changes how it moves and interacts.
So shorter wavelength equals more energy, like a quick burst.
Exactly.
Yeah.
Now, let's talk frequency. This is how many waves pass a certain point every second. Picture a drummer going crazy on a snare drum. High frequency means they're hitting that drum super fast, making a really high-pitched sound.
So frequency is about how fast the wave is vibrating, and that changes the sound we hear.
You got it. Now close your eyes and imagine you're at the beach. Picture those waves crashing on the shore. That height, from the bottom to the top of the wave, that's amplitude. Higher amplitude means more energy in the wave, like a bigger splash.
Okay, so wavelength is like the width, amplitude is the height.
Pretty much, yeah. And then obviously we've got speed, which is just how fast the wave itself is traveling, just like how fast a car is moving. And then there's the period, which is how long it takes for one whole wave to pass by, like the time between two claps and a slow clap.
Okay, so those are like the ID cards for waves.
Exactly. But here's where things get super interesting. It's not just about the wave itself, but how it interacts with the world around it.
Wait, waves can interact?
They definitely react to their surroundings. Think about this. What happens when you throw a ball at a wall?
Well, it bounces back, obviously.
Exactly. And guess what? Waves do that too. When sound waves bounce off something, we hear an echo. Light waves bouncing off a mirror is how we see our reflection. Even sonar, the thing submarines use, relies on sound wave reflections to navigate underwater.
That's so cool. What else can they do?
Let's say you're skating and you hit a patch of sand. What happens?
I'm going to wipe out. But seriously, I'd slow down and probably change direction.
Right. Light does something similar when it goes from air to water. It bends because it slows down. It was called refraction. It's why a straw in a glass of water looks broken.
Refraction. So that's how that works. What else can waves do?
Have you ever noticed how you can hear music from another room even if the doors only open a crack?
Yeah. But how does the sound bend around the corner?
That's called diffraction. Waves can bend around stuff or spread out after going through an opening.
Okay, I'm starting to see waves everywhere now. But you said something about waves interacting with each other.
Yeah. That's called interference. And that's where things get wild. When two waves collide, they can combine. Sometimes they line up perfectly, creating a bigger, more powerful wave. Imagine two friends pushing a swing at the same time it goes higher, right? It's like that with waves: louder sound, brighter light, more energy.
Cool. But what if they don't line up?
Then it's like pushing a swing at the wrong time. It messes everything up. That's destructive interference, and it's actually how noise-canceling headphones work. They make sound waves that cancel out the noise you don't want to hear.
Wait, so it's like a wave battle happening in my ears? That's crazy.
Pretty much. And it's not just sound either. Light waves can interfere too, which is why you see those cool patterns on soap bubbles.
Yeah.
It's all thanks to light wave interference.
No way. So waves can bounce, bend, spread, and even fight each other. Is there anything they can't do?
Well, they can also be absorbed. Picture a black car in the sun. It gets way hotter than a white car.
Because black absorbs more heat.
Right. The black paint is soaking up more of that light energy and turning it into heat. Sound waves can be absorbed too. It's like when you have those thick curtains that block out the sound from outside.
Okay, I need a minute to process all this.
Yeah.
But this is super cool.
It really is. And we're just scratching the surface here.
Oh, wow.
There's so much more to learn about waves. Like, remember how we were talking about light waves being electromagnetic?
Yeah, the ones that can travel through space.
Well, light is actually only a tiny part of a much bigger thing, the electromagnetic spectrum.
A rainbow or something?
Kind of. It's like a giant family photo of all the different types of electromagnetic radiation. We arrange them by their wavelengths and frequencies from super long radio waves to tiny gamma rays.
So are there other waves out there besides the light we can see?
Absolutely. Our eyes can only see a tiny bit of the electromagnetic spectrum, what we call visible light. But there's a whole invisible world of waves out there.
Invisible waves. That's kind of creepy.
Not creepy, just super cool. For example, radio waves have way longer wavelengths than visible light. That's why they can travel super far and carry information, like your favorite radio station.
So that's how radios work. And what about Wi-Fi? Is that waves too?
Exactly. Wi-Fi uses radio waves to connect our devices. Then there are microwaves, which, well, heat up our food.
Hold on, the same ways that cook my popcorn.
Yep. It all comes down to the wavelength and frequency. And on the higher energy side of the spectrum, we've got X-rays and gamma rays.
Oh, like X-rays at the doctor's office.
Right. X-rays have much shorter wavelengths than visible light, which lets them pass through our skin and muscles. But they get absorbed by denser stuff like bones, and that's how doctors can see your skeleton.
So we're basically swimming in a sea of invisible waves all the time. That's kind of freaky, but awesome.
Think of it as like a hidden world that we're just beginning to understand, and we're just starting to see how we can use waves in technology.
How do waves power our tech?
Well, we already talked about radio waves for communication, but they're also used in radar, which helps planes and ships navigate. And then there's ultrasound, which uses sound waves to create images of the inside of your body.
Like when doctors check on babies before they're born.
Exactly. Ultrasound is amazing because it doesn't hurt at all and it's safe. And speaking of sound, did you know that music is all about waves?
Yeah, duh. It travels through the air.
Right. But different musical notes are actually made by sound waves with different frequencies. When you play an instrument, you're basically making patterns of waves that our ears hear as music.
So when I'm jamming out, it's all thanks to waves. That's awesome. What else can waves do?
Let's talk about light again. Have you ever wondered how we see colors?
I just thought things were different colors, like grass is green and the sky is blue.
That's true, but it's light waves that make those colors visible. White light, like sunlight, is actually all the colors of the rainbow combined.
Really? But how do we see them separately?
When light hits something, some wavelengths are absorbed and others are reflected. The reflected ones are what determine the color we see. So a red apple absorbs all the colors except red, which bounces back to our eyes, making it look red.
So colors are just light waves bouncing back at us. Whoa.
And think about rainbows. They're formed when sunlight is bent, remember refraction, and reflected inside raindrops, splitting the white light into all the colors.
Okay, now I'm seeing rainbows in a whole new light. This is amazing.
And don't forget about lasers. They use light waves to make a beam of super focused light.
Lasers, like in sci-fi movies?
Haha. Well, maybe not quite like that. But lasers are used for tons of cool stuff, from super precise surgery to scanning your groceries at the store.
Wow, waves are behind so much.
Totally. From the tiniest atom to, like, outer space, waves are at work, shaping and connecting everything.
My mind is officially blown. I feel like I'm just starting to get how amazing waves really are.
And that's the best part about science. There's always more to explore.
I'm definitely seeing things differently now.
I bet. So what can our listeners do if they want to keep learning about waves on their own?
Yeah, what should they do?
Well, next time you're listening to music, see a rainbow, or even just look in a mirror, remember you're seeing waves in action. Just start paying attention and see if you can spot how waves work. You'll be surprised by how much you notice.
That's great advice. Maybe some of our listeners will even want to become scientists and discover even more about waves.
I hope so. We still don't know everything about waves, and there's a ton of stuff left to discover.
Well, on that note, we're going to wrap up this episode. All our listeners, keep those brains buzzing and never stop exploring. Until next time.